Example 5. We're going to do another synthetic division, but we're going to have two curveballs coming at you right now. The main curveball is the 3 there in front of the x on the binomial. Synthetic division doesn't work well for weird coefficients like that in front of the linear part of the binomial. Um, so what we do is we do something kind of odd. I'm going to take every single term in the binomial that we've got, and I'm going to divide it by 3. So each one of those things is getting divided by 3, which is going to give me a lot of fractions. But that's okay, we can handle it. So it's going to get me, and what's nice here is I'm also actually going to divide each of these parts by 3 as well. And I get 1x to the fourth minus 5 thirds x cubed plus 1/3 x squared plus 7 cubed, or 7 thirds x, is being divided by 3 divided by 3 is 1, and 1 divided by 3 is 1/3. Now I have myself a divisor that has a coefficient of 1, so I can use the same process I did before. So I start off with my x to the fourth term. Its coefficient is 1. X cubed is negative 5 thirds. X squared is 1/3. 7 thirds for the linear part, and I notice here there's no constant in this, so I have to put a 0 down for the constant. Then I check my binomial dividing by. It has to be equal to 0, so I'm going to have negative 1/3 as my number that I'm going to use in the synthetic division. And set it all up here with a line. And now I've got myself my synthetic division all set. And remember, the process is drop, multiply, add, repeat. So drop the 1 down. Multiply it by negative 1/3. Now maybe I'm gonna give myself a little bit of extra space here on this one, since I got fractions. I don't want them to be too tight. Multiply it by negative 1/3. Negative 5 thirds plus negative 1/3 is negative 6 thirds. Guess what that is? That's 2, isn't it? So are you okay with me just changing that negative 6 thirds out to be a 2? I'll write it in red there. Now negative 1/3 times 2 is negative 2 thirds. Negative 2 thirds plus 1/3 is negative 1/3. And then I got negative 1/3 times negative 1/3 is positive. Oh, wait a second. Hold on. This was supposed to be a negative down here because I'm adding two negatives together. A negative times a negative is positive. There we go. Almost made a mistake there. I'll tell you, the one thing that does get people the most on this is this negative sign on here and making sure you keep track of it when you multiply. Negative 1/3 times negative 2 is positive 2 thirds. Add those together, you get 3 thirds, or 1. Negative 1/3 times 1 is negative 1/3. Add those together, you get 6 thirds, which, hey, guess what? Again, that's 2. Negative 1/3 times 2 is negative 2 thirds, and add that to 0, you get negative 2 thirds. But remember, this piece down here is the remainder. All right. So, I remember this started with an x to the fourth. So my answer here is going to start with an x to the third. So I'm going to have 1x cubed minus 2x squared plus 1x plus 2, And now I've got this remainder here. I'll just go say plus negative 2/3 over the original, what we were dividing by, x plus 1/3. Now, what's kind of interesting on this next part here is how to deal with the remainder part of it. This is also kind of tricky. You can see the level of complexity goes up quite a bit for finding something with a non-1 coefficient in the divisor. So we have negative 2/3 divided by x plus 3. If you think back to what division means, like if I have 4/5 divided by 7/2, that really means 4/5 times 2/7, right? So that's what I'm going to do on this little bit here. Negative 2/3 divided by x plus 1/3. That's going to change into negative 2/3 times 1 over x plus 1/3. I don't know if I really like that right there. Yeah, that's fine. Oh, you know what? Let me take that back. I want to simplify that x plus 1/3 first. I don't really want x plus 1/3. I want to change the x plus 1/3 into something. And the way I'm going to change that is by figuring it out so it's one nice big fraction instead of the two binomial parts there. See, that's where I got into trouble, is I didn't have a nice fraction like this to take the reciprocal of. So what I do is I find a common denominator, 3x thirds plus 1/3, and that gets me 3x plus 1 over 3. Hey, look at this. 3x plus 1, 3x plus 1. That's not a coincidence there. All right. Now I've got myself a fraction, and now I can actually do the negative 2/3 divided by 3x plus 1 over 3. And I change that into negative 2/3 times 3 over 3x plus 1. Well, guess what? Those 3's cancel, and all we're left with is negative 2 over 3x plus 1. So these two green spots here are equivalent. That's a little bit of trickiness there to find those things being the same. But now let's write it out here. X cubed minus 2x squared plus x plus 2 minus 2 over 3x plus 1. And there's my result.